Hey, good morning, Ag Structures people. Today we're going to move from identifying weld positions and steel types into MIG welding with the hopes of getting to this lab work when we return to school. So I am going to post on the Google site a picture, and as I go through these notes, you can refer to this picture. The picture's here on slide number 2. And it just has all the parts of the MIG welder numbered that we're going to review this morning. We're going to talk about those parts and what their function is, and then there's some questions to answer on a worksheet at the end. So let's get to some MIG welder parts. In the picture here, you can see that we're going to cover 8 things this morning: 1, 2, 3, 4, 5, 6, 7, and 8. Part number 1 is called the compressed gas cylinder. This is just a tank that holds the shielding gas for the welding process. So it stores that volume of gas. It's under extremely high pressure, which we'll talk about in a second. And when that cylinder is open, then that gas is emitted during the welding process. Number 2, you can see it up here. Number 2 is called a gas pressure regulator. So it has a lot of functions. On that regulator, there are 2 gauges. The gauge on the right of our machine indicates the tank volume pressure. The left gauge indicates the flow pressure. So I've got a slide here. The right gauge, this is going to tell us how much pressure is in the tank coming out of this valve, the top part of that compressed gas cylinder, that tank. On this gauge, you see 2 sets of numbers. In red, we have PSI, and then in black, we have KPA, kilopascals. Some gauges also use bar as a pressure measurement. You can see that this pressure volume is extremely high. So this is a measurement of force for volume. We use PSI for tires. 35 pounds of air in your tire. PSI, pounds per square inch. So in 1 cubic little inch, there are 1,000 pounds of pressure. If you want to think about it, 50-pound feed sacks, that is 20 of them in 1 little cubic inch. That's a lot, okay? And then that whole volume of the cylinder is filled with that much pressure at this particular moment. The other gauge on the left on this particular regulator, we've got an increment that tops out at 35, and then we have 50 on the outside, CFH. Most of the regulators that I see, they're both PSI and bar. This particular one's using kilopascals. I think this picture came from Britain, so they've got, there's tons of other options based upon where you are in the world. You also see this adjustment dial. This dial regulates the airflow coming through the hose. So when we adjust it, it's going to alter this reading in the needle on the left gauge on this particular setup. I have in the notes left and right. That is not always true. Some of these regulators are designed backward, or backward from this particular setup. So the right gauge is the one closest to the valve, and it's going to be the pressure gauge, or the left gauge is closest to the valve, and it's going to be the pressure gauge, and the right is going to be your flow gauge. The rule of thumb is the gauge closest to the valve is going to tell us the pressure in the tank, and the other gauge is going to tell us the flow. A couple of things to note. When you are opening a cylinder of compressed gas, be it for using the torch or a MIG welder, we call that process of opening the cylinder cracking. You never want to stand in front of the orifice on the valve or where that pressure regulator is threaded in. A couple of reasons why. Number 1, if someone had installed that regulator incorrectly, or they started to install it and they got they got distracted and walked away, it may not be fully, the threads may not be fully engaged in that valve. And I have seen, for whatever reason, people set them up there and then they walk away, and then individuals go turn that gas on and that regulator shoots out and becomes a projectile. And if you want to think about 1,000 PSI gas shooting, it's going to have a considerable amount of force behind it. So you have to be aware of that. Another reason there could be a malfunction in this pressure regulator. I have seen sometimes these gauges, for whatever reason, they're compromised and the gas starts to actually shoot out. You know, there's just a small little valve in here that reads the pressure of gas, and things wear out, they deteriorate. So when you turn that gas on, if the valve stem in these gauges is compromised, these face plates and these covers can become a projectile. So you always want to stand on the opposite side of the regulator. Number 3 is the outlet plug, like the welders, the Lincoln stick welders that we have. This particular welder utilizes the three-prong welding plug. Some small welders, MIG welders, they do operate on 120 volts, and I have a friend that's got one, and it works extremely well to operate off of a particular, or just a standard household outlet. If you are using 120 volt MIG welder, you want to make sure that the amperage of the breaker in the panel that you're welding with is sufficient to handle that. Otherwise, it may trip the breaker. If there's a malfunction with the breaker, it could actually cause an overload to the system, and you could see an electrical fire. So just something to be aware of. Most of the time, these welders are going to operate on 240 volts, and they even make some models that can switch back between 120 and 240. Again, when we are plugging this welder in, or any welder in, even if it's the BuzzBox, the Lincoln welders that we have, or MIG welder, we want to make sure we're keeping our contact on the plastic or rubber coating of that plug only. We do not want to ever touch those metal prongs. Number 4, we have the ground clamp. The ground clamp on this particular MIG welder is an alligator style, just like the BuzzBox stick welders. One type of clamp that you might see if that you go on to be a welder is a C-clamp style, which I actually prefer. You have a terminal lug, which is just a blade here on the lead, and then you have the actual ground wire going into that lug, and then it just bolts on to that clamp there, and you can crank that down. The downside to those is sometimes they're a little more difficult to get onto a piece if that you're actually making a repair style weld. You need some more room than you would on the alligator style. On the other side, though, you could remove this bolt from the lug and then just set that ground on that piece of material with a pair of vice grips, or you could actually thread a bolt through that piece that you're repairing. Just like with stick welding, we want to make sure that our material that we're welding is free of rust and it's free of paint. That is going to ensure the best flow of electrons through that system, and a clean ground is the best way to start. Number 5, we have the welding gun. We're going to talk about the welding gun in greater detail tomorrow, but this dispenses wire and shielding gas. So what we have are just some different parts, and it plugs into the front of the machine. We'll go through how we get that wire and what that process is tomorrow. Number 6, one of the 2 dials. This dial is called the voltage dial. It is indicated by the V next to the dial. This will select the voltage that you are going to use for welding. So most of the time, the voltage is going to top out at 240 volts because that's all the voltage that's coming through that outlet. Sometimes on these welders, they can actually just have, so this panel uses a digital, which is the same style as the MIG welder we have. This particular welder here just has a dial, and you just click over to the setting that you want. Number 7 is the wire feed dial, and as you can see, it's the same sort of thing. This just adjusts the speed at which the wire comes out of that gun. We'll talk more about that tomorrow. It's going to be dependent upon the MIG welding application that we use. Number 8 is the power switch. This turns the welder on and off. And that's it, guys. If you would, go ahead and answer those questions for me and then share them with me. And we will see you tomorrow to talk more about MIG welding. Thanks.